wanted to walk through some of the more complicated polar equations from the book. So this is one that started out with some nice color coding. I just want to talk about why everything ended up where it ended up. So we've got our first chunk, this blue chunk. I suppose I should also probably use blue. Blue chunk. Okay, it goes from 0 to pi over 2. And so in the polar coordinates, 0 to pi over 2 is right here. And it goes up to 3. And we can see that this one also goes out to 3, like it should. So that makes sense. I'm in that area and I go out to 3. Okay, so then if we go back over here and look at this green one. This green one, it's from pi over 2 to pi. Well, pi over 2 to pi is right here. And it goes out 3. So why is this not green? Okay, and the answer to that is because it actually goes out -3. And if we recall, when r is negative, we move in the opposite direction on our line. So anywhere that we have plotted a point between the angles, pi over 2 and pi, it's going to end up moving backwards on our ray. And so from pi to pi over 2, all of our rays are reflected, and that's why we end up with the green down here. Okay, let's look at pink. Pink goes from pi to 3 pi over 2. So pi to 3 pi over 2, that's right here. It goes up to 3, and that goes out to 3 like it should. Everything kind of makes sense there. So now let's look at the gold piece. Close enough. Orange. Okay, so orange goes from 3 pi over 2 to pi over 2. So from 3 pi over 2 to pi over 2 is right here. And it goes out 3, so why do I not have an orange flower petal right here? And that is again because this is going down to -3, so it's going to force everything backwards on the ray between 3 pi over 2 and 2 pi. So all of my rays in this section are going to be backwards because of the -3, which is why I end up with the orange section over here. So because blue and pink are positive, they are in the angles where they seem like they should be. Because green and gold are negative, they're in the opposite quadrant from where it seems like they should be. So green was pi over 2 to pi, should be in this quadrant 2, but it's actually in quadrant 4 because of the negative ray. And then here, gold or orange, is 3 pi over 2 to 2 pi, that should be in quadrant 4, but it's actually in quadrant 2 because of the negative ray. Okay, so this is sort of showing us the exact same thing. Converting between the two. I've got all of my positives should end up sort of where they belong. So all of these. And then all of these negative pieces should end up in the opposite quadrant because they're going to go in the negative r direction. So let's just take a couple of these. Let's take this and go see if we can find it. So this is the I piece, and it's showing I is between, it's about pi to 3 pi over 2, somewhere in there. And it's right here where it should be. So it doesn't quite go from pi to 3 pi over 2, but it's in between that, so it's in the quadrant where we would expect it to be. And if we look instead at, I guess I'll put that back. See this blue piece K. Now we would probably also expect this to be crossing right here. So it crosses 3 pi over 2. 3 pi over 2 is right here. So we might expect a flower there. But instead, because it's negative, it's going down to -2-ish. It's an official math term. It goes up because it's going to be forced negative on that ray. Okay, and then the last one talks about how to know when we graph the entire graph. So if we're looking at this and we figure out our range is 0 to 5 pi, and we actually graph it, we don't get the entire graph. We get this partial spiral. When we graph the entire graph in its polar coordinates, we should end up back where we started. And so the book is making the argument that the complete curve goes from essentially 0 to p, where p is equal to f of 0. So we need to find an integer multiple for 5 pi, which is our period, that makes pausing while I make sure I have this right, f of 0 is equal to f of p. Okay, so we need 0 to 10 pi because 10 is the closest multiple. If we look at r is equal to cosine of 2 times 0 over 5, and that gets us 1. 5 pi won't get us there. 5 pi gets us to -1, so the next closest integer multiple of 5 pi would be cosine of 2 times 10 pi over 5. The 5 here would cancel with this 5, and this 2 would cancel, double with that, so it would give us our cosine of 4 pi, which would give us back to 1. So we had to find an integer multiple of the period that would get us back to the point where we started, so that we would know we had a complete graph, because we should have ended up back where we started when we were done graphing this. So that's a short explanation of the argument that the book is making with this f of 0 equals f of p. We're just looking for the closest integer multiple of the period that will get us back to where we started, rather than ending us in a new spot.